Hi everyone, welcome to Python Code Nemesis. Let's look at the question from the Google card on leetcode's list of questions. This is the meeting rooms 3 problem. You are given an integer n. There are n rooms numbered from 0 to n minus 1. This means that if n is 7, we have the rooms as 0, 1, 2, 3, 4, 5, 6. You are given a 2D integer array meetings where meetings of index equals start of the ith meeting and end of the ith meeting. This means that a meeting will be held from the start time to just before the end time. It is also given that all start times are unique. There are a few conditions given for allocating meetings to rooms. Each meeting will take place in the unused room with the lowest number. If there are no available rooms, the meeting will be delayed until a room becomes free. The delayed meeting should have the same duration as the original meeting, so basically the meeting just gets shifted to a later time. When a room becomes unused, meetings that have an earlier original start time should be given the room. The problem is to return the number of the room which held the maximum meetings. If there are multiple rooms, return the room with the lowest number. Let's look at an example to understand this better. We'll be taking this example itself. So here we can see that, let's write it down. So n equals 2 and the input meetings is 0, 10, 1, 5, 2, 7 and 3, 4. This is the input. This means that the rooms that we have are 0 and 1. These are the rooms. Notice that in this example, the meetings are sorted by start times, which is 0, 1, 2, 3. These are the start times and it's already sorted by start times. The input might not always look like this. So we might need to sort this based on requirements. Let's draw a timeline to understand this better. For ease of understanding, let's call this meeting 0, let's call this meeting 1, let's call this meeting 2, and let's call this meeting 3. Now, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have rooms. We need to allocate meetings for these rooms. At a certain time, we'll have two types of rooms. Either the rooms are going to be free or they are going to be busy. Now, at a certain time, what are the options that are there and how is it happening? So let's put time. So this is the current time. This is options. These are room options that are available, which are free rooms. And then we have the room chosen. So this is the room chosen. So time, let's start from time 0. What's happening at time 0? This task is starting. This meeting is starting. So what are the options that we have? 0 and 1. So we'll use room 0. So we chose the room 0 and let's have a array. So let's have this array and this is room 0, this is 1. So we got 1 here. One meeting is happening in room 0. When is the end time for this meeting? It's at 10. So meeting 0 will occupy this room 0 till the 10th time. So let's write this down. Room 0, meet 0. So this is what's happening. And then 0 gets removed from our options. Now we have time 1. At time 1, is there a meeting that's starting? Yes, the first meeting is starting, this one. So what are our options? Our options is just 1 because we just have one free room and the room that's chosen is 1. Now, this is where the task will start and it should go on till just before 5. So this is room 1, meet 1. So this is what's happening. Now we are at time 2. Is there a meeting or a bunch of meetings which are waiting to start at this time? Yes. But do we have any options for the room? Nope. So we can't do anything. Next. Let's go to 3. What's happening? The room options are nothing. There are no free rooms, so we can't do anything. At 4. Is anything happening at 4? Do we have any empty rooms at this time? Nope. Close. What's happening at 5? Now at 5, we see that room 1 is becoming empty now. So we have it in our room options. And at the 5th second, we see that we have these 2 tasks that are ready, these 2 meetings that are ready. So we'll choose the meeting 2 with the earliest start time. So let's choose room 1 again. And in room 1, meet 2 will happen till how long is this for? So the duration of this is 5. So 2 to 7, meeting 2 will take 5 seconds. So let's write this down. So room 1 again and meeting 2, which is taking 5 seconds, and this ends at 10. Now at 6, do we have any rooms empty? No. At 7, no. At 8, no. At 9, no. At 10, we have 2 rooms empty because both these rooms become empty at 10. So room 1 and room 0 both are available. Which one will we choose? We'll choose the one with the least index value. So we'll choose 0. So we choose 0 and how long will this meeting go on for? 4 minus 3 is 1. So it will go on for like 1. So it will go on till 11 and then and then all the tasks, like all the meetings are done. So we see that 0 had 1, 2, and 2 and 1 also had 1, 2. So we had 2 rooms that got used the most. So 0 got used 2 times, 1 also got used 2 times. It's given in the question that if there are multiple rooms that held the most meetings, return the room with the lowest number. So our answer will be 0. So this is what we want to return. Hope this was clear. Now we'll just move on. Now that we know how to solve this question, we need to consider a few things. So at every instant, we need to know what are the free rooms and what are the busy rooms. Also, at every instant, we need to know what are the meetings that are ready. So meetings that are ready to start. So these are the 2 things that we need to know at every instant. Now, in these free rooms, we must always need the room with the least number to allocate a meeting because that was given in the conditions that if there are multiple rooms, like let's say 2, 3, 1, we want to choose 1 because this has the least number to allocate a meeting. Having to find the smallest element in a changing list because it could be that it's 2, 3, 1 and then after some time 2, 3, 1 and 5 comes in because that becomes free at a different instant. And at every point you need to find out the minimum in this list, and this is a changing list, so that would be a very costly operation. To make this faster, we can use a min heap or a priority queue so that the cost of getting the smallest element is big O of 1 and then the heapify itself takes big O of log n, so the time complexity can be reduced. Okay, so that was for free rooms. Now for the busy rooms, when we store busy rooms, we also need to know when this room will become free so that we know when to add it back to this free list of rooms, or now as we are calling them in heap. So we want to add the, like something becomes free, when to add that room back to the free. For that, we need the end time for the meeting which is going on in this busy room. So whenever here in this example, at 0, when we chose the room 0 here, we need to store the end time. So the end time for this meeting was 10 for room 0. So we need to like have this value somewhere. So this one is what I'm talking about. This we need to store, the end time and the room, so that we know when to add it back to this free heap. So in our busy list, we will store something like this. So we'll store something like end time and the room number or index, whatever we can say. Let's take an example. So let's say the end time is 5 and the room number is 7. Let's say current time, like current time is equals 3. This means that the meeting in room 7 has not ended yet. Similarly for 4 and yeah, so similarly for 4. Now let's say the current time is 6 now. Current time is 6 now. You see that the end time of this one, of this task, 5 is less than equals 6. So the meeting in this room is over and this room 7 is free now. You need to remove it. So you need to remove this and then put it back into the free heap of rooms. So that's what. Now let's say busy looks like this. So let's say this is our busy. So what we wanted to do is have an end time and a room number. So this is like you can um, take this as a tuple, right? You see here as a tuple, and then you have a, let's say what happens when you have a normal list. You will have, this is the end time and this is the name of the number of the room. Let's take an example like this and 5 7. So this is the end time, this is number, end time number, end time number. Now let's say current time is equals 3. What happens when the current time is equals 3? Think about it. This means that room 1 and room 5 are done with meetings and need to be moved to free. So these were in busy, these two both need to go to free. So 1 and 5 should be free now. Here again, you need the meeting room with the least ending time to pop from the list. So you need to see like which of the ending times are less than um, the current time to pop. With a list, if you were trying to get the smallest number in the list every time and check if it is less than the current time, that would be a big O of n every time. So we can use a priority queue to give us the meeting room with the lowest ending time in a big O of 1 time complexity. We can just look at the top of the heap and pop that meeting room with its end time only if it is less than the current time. So that will save us a bit of time. So what we understood is that we need two min heaps, one for free rooms because we need the least number every time, and then one for busy or busy rooms, which is a tuple of end time and the room. So this is what we need, and I think we have everything we need to start writing the code. So let's get started. So this is our function def most booked self and meetings. This is how we do it in Python. So just an empty list. Also from heap q import heapify heap pop heap push. Python only supports a min heap, so if you want to have a max heap, you'll need to negate that element and pass it in. But here we just need to min heap, so we're good. An empty, busy. This is gonna be a heap, min heap. And then we have free, which is the rooms that we have. I for I in range n. So if n is 3, then this free will have 0, 1, and 2. Now, you want to heapify this, so heapify free. And then we need to sort the meetings in the order of start time, so sorted meetings. This will automatically sort it in the order of start times in Python. The first element in the tuple, so because it had S and E, it will get sorted by S first, which is all we need. Now we need a count array. So what we need is something like this. So 0 and 1. So it will have 0. So this is one room, 0th room, first room, and then like second room. And initially it's all 0 because the number of meetings that happened in each of these rooms is 0 for now. So 0 for I in range n. Max count. This is something to just store the max count that was there throughout so that we can just return it in the end. And then max count room. Yeah, we need this is what we need to return in the end. Initial value we're just putting. Next, let's do the actual thing. So for start and end in meetings, this is how we do it in Python. While there is something in the busy heap, and the top element busy end time, this is top element end time is less than equal to start, which is basically the current time right now. We pop and store it, so end time room is equals heap pop busy. So this is where we are popping. Like the first thing that we do when we are when you're processing a new meeting and we have the start time of that meeting is first we need to see what are the servers that were previously busy, which might be free right now, which might, help process the meeting that we have right now in that room. So we need to see what are the free rooms first. What are the busy rooms that became free? So this is the first thing that we do. And then heap push this into the free heap and the room name. Now, so first thing that we did is popped from the busy. So if there was anything in busy and the start, like the end time of that meeting in busy is less than equal to the start time, then we have it in the free servers. So there are two possibilities here. We either have free rooms or we don't have free rooms. So if we have a free room, then that's really cool. There is nothing to worry about. Room is equal to heap pop 3. So this gives us the room with the least number, the condition that was given in the question. And then heap push this into the busy because now we are using this. And this is going to be busy. This room is going to be busy till the end of this meeting. So we just put that here and that's great. Else, if there is nothing free, then we'll need to pop the meeting from the busy heap with the least end time and then allocate this meeting to that room. This meeting is going to take place only when that meeting ends. So end time room is equals heap pop busy gives us the room with least end time, and then we do a heap push into busy again. Now this time this will be end time, which is the end time of the busy server plus the duration of this meeting. So as long as it takes, so n minus start is the duration and the room number. So that's it. Now that we did this, the count of the room that we just used will go up by 1. So if count of room is greater than max count, now we need to update our answer. So max count will be count of room, max count room will be equals to room. There was also this condition which said that if there are multiple rooms with the max count, then just give us the one with the least index. So we'll have another condition for that. So if count of room is equals to max count and room is less than max count room, then we need to update it again. So max count is equals to count room, max count room is equals to room. So basically the same thing that we did here. We can put both of these into one single condition as well. In the end, we'll just return this max count room. All of this part that I did here, which is a lot, instead of writing all of that code, you can just do count dot index of max of count, and this will give you the max count room in just one line, so you don't need to write all of that. That was it for this video. All of the code for this will be available in my GitHub link. So if you want to run the code and check it out, you can do that from there. Thanks everyone. Have a great day.